All right, here we have a uh, standard normal conversion problem. Remember, there's only two, at its essence, there's only two ways to do these. Conversion where you have the portion above or below, and you're needing to get the cutoff, or one where you have the cutoff and you want the portion above or below. Everything else is just a combination of one of those two types of conversions. So in either case, let's start off by drawing a picture, always the best way to handle these. Give ourselves a visual. This helps us avoid mistakes like forgetting to subtract from 1 or getting on the wrong side of the distribution. Okay, so here we are looking at a mean of 580 and standard deviation of 120. So just put that there. Oops, standard deviation equals 120. And what do we want? We want the individuals who exceed 800. So we're looking for, maybe I'll change my color here. So somewhere up around here, doesn't matter. Yeah, that wasn't super, that wasn't too bad. This score here, x equals 800. So what do we want? We want the portion of individuals who score above. The word exceed tells us we want this right here. This is what we're trying to find. So again, we have a cutoff. We're trying to get the portion above. Now, we can use an ALEKS calculator to give us a useful bit of information here. But in order to use it, we need a z-score. So here we're going to use our formula we'll be using a lot. And we have the x value. So let's put that in. 800, we know our mean is 580. And our standard deviation is 120. So if we solve this here, we get, do it real quick over here to double check, should get 220 divided by 120, which will be 1.83333. Let's carry these four decimal places. 8, like this. Okay, now we're ready to go to the calculator. So we need to find the portion below or above that. Specifically, we need the portion above. But when you think about it, if you can get either one, then you're really close to the answer. Either you have the answer or you're one small step away from it. Now, unfortunately, the calculator always gives us the portion to the left. Hear that very closely. When you have a z-score, the calculator will give you the portion to the left. Now this is a bit easier to see because it actually shows that. If you see portion of z-scores that are less than or equal to a z-score of 1.8333, and this would be 0.9666, and we're supposed to round to at least 4, so let's do put that in there. 0.9666. Now, let me point out here that this matches up with our drawing, except, wait a minute, something's wrong, right? We're looking for these potential leaders, and hey, that doesn't seem to match our drawing. Well, as it turns out, remember, the calculator gives us the portion to the left. So this is 0.9666, 96.66%. But that's not what we want. We want the portion to the right. We want the portion above that cutoff. So this is where we need to take 1 minus 0.9666, and that will give us 0.0334. Here is the portion to the right. So how did I know that? Well, I caught that error because of the picture. I knew that I was looking for just a tiny chunk of our distribution. So when the answer gives me 96.66%, I'm thinking, okay, something's fishy here. So this is, again, reinforcing the concept of why these drawings, these visuals are so important on these types of problems.